Okay. Right. Good evening. We'll start. Online, can you confirm whether I'm audible? Okay. Right. We'll start. We are in paper 8 today. We are in paper 8. Right. So this week onwards, this paper onwards, we'll be having 35 MCQs. Right. In part 2 papers, probably you will get 3 structured essays and 3 essays. Right. So we are upgrading the structure now. Right now, today itself, also you got 35 MCQs. Right. 35 MCQs. Right. So we'll start. It's 7-2 now. You can write first 10 questions today. Right. First 10, not first 5. Right. First 10. It's 7-3. Write it by 7:15. Right. Write by 7:15. First 10. Let me know if any typing mistakes. I checked the paper today, but let me know if you notice any typing errors. We don't know the equation of surface tension, that is F equals TL, where T is surface tension. Right? Where T is surface tension. Surface tension. Surface tension is coming in unit 10. Here. Okay. Let's see. First one. First one, very straightforward. Dimensions of impulse. Dimensions of impulse. As an equation, impulse is either ft or delta mv. There are two equations for impulse. I equals ft or delta mv. Right? Use any of the equations. mv no, then mass is m. Velocity is lt minus 1. Dimensions of impulse mlt minus 1. Dimensions of impulse and linear momentum are equal. Dimensions of impulse and linear momentum are equal. mlt minus 1, it's 2. For first one, it's 2. Right? For first one, it's 2. Second one, the ways that 3 students have written the units of linear momentum are given below. Right? kg MOS, kg ms minus 1, kg MOS. The correct forms of the unit according to SI system is R. Right? So first rule is according to SI system, there should be a small gap between two different units. Right? There should be a small gap between two different units. Right? There is no gap between the prefix and the unit. Right? If you are writing two different units, as an example, these two, this is kilometers, this is kilometers, this is kilometers. No gap between, no gap in between, because these are prefix. These are prefix. No gap in between. And this is Kelvin meters. This is Kelvin meters. There's a small gap between these two because they are two separate, two different units. Right? So that is one thing. In A, there is no gap kept between kg and meters. They are two different units. So A is wrong. B is correct. Kg is separated, meters separated, per second separated. B is correct. C is also correct. Right? S minus only another, we can write it as 1 OS. That's totally fine. Right? Kg MOS, both B and C. ms minus 1 or s minus 1 can be written as 1 OS. That is fine. Right? SI unit then B and C. B and C, 5. The second one, it's 5. Three. What is the unit of moment of force? Very easy. Moment of force. Equation of moment of force is moment of force G. Equation of moment of force is force times perpendicular distance. Right? You need unit. Then unit is Newton meters. Newton meters. Newton meters. Next one. Which of the two sets given below are same in dimensions? Surface tension and pressure. I gave you the equation of surface tension, that is F equals TL. Now from this, if you check the dimensions of surface tension, it is MT minus 2. It is MT minus 2. Dimensions of pressure is ML minus 1, T minus 2. So they are different. They are different. Right? Relative density is dimensionless. Relative density is a ratio between densities. Dimensionless. Relative velocity is a subtraction or addition of velocities. Relative velocity has the dimensions of velocity. Right? Relative velocity क्या है velocity का? Work and torque. That's correct. Because work is force into displacement, and torque is force times perpendicular distance. Torque is the force moment about point of rotation. Force moment about point of rotation. Right? These two are same. Dimension is same. Answer is 3. And check change of momentum. Change of momentum is delta mv into force when ft. Delta mv equals ft, not f. Right? Then power and efficiency. Power is energy over time. Then dimensions ml square t minus 3. Efficiency. What is efficiency? What is efficiency? So 4 answer is 3. What is efficiency? Efficiency. As an equation, what is efficiency? As an equation. Efficiency. This is not something you have heard in A levels. Efficiency is something you should have heard from O levels as well. Efficiency. Any efficiency is output over input into 100%. Efficiency is a percentage. 80%, 50%, something like that. Efficiency it is a percentage. Power output or power input. Not limited to power, right? Any output over any input. Right? Say there is energy, then energy output over energy input. Then current, output current over input current. So likewise, applicable anywhere. This is general equation, output over input into 100%. That is a percentage, right? Dimensionless. Efficiency is dimensionless. Right? So it's work and torque. Work and torque. Five. The diagram shows a micrometer screw gauge with 1 millimeter pitch. 1 millimeter pitch. What is the pitch of our typical micrometer screw gauge? 0.5 millimeters. Right? Pitch of our typical one is 0.5. Right? So this given one is not the typical one. 1 millimeter, 1 millimeter pitch. The jaws are coincided. The drum of micrometer is divided into 50 equal parts. Which statement below is true? Okay. So first of all, find the least count. This is not the typical one. Least count is pitch over. Least count is given by pitch over number of divisions in vernier scale, number of divisions in circular scale. Number of divisions in vernier scale. 1 second. Pitch is given as 1 millimeter. Pitch is given as 1 millimeter. Number of divisions 50. It gives 0.02 millimeters. This is the least count now. This is the least count now. Right? If 0 is above center line, that is a negative error, because always we rotate the instrument towards user, towards us. Right? We rotate the instrument. Right? You rotate the thimble towards us. Now 0 is starting somewhere behind it's supposed to be. So it's a negative error. Negative 0 error is given by total minus coincided. Coincided 48, ne? 48. 48 times least count 0.02. That is 0.04 millimeters. 0.04 millimeters, and it should be added. 0.04 answer, it's 5. It should be added. That's a negative error. It should be added. Right? Micrometer screw gauge එක දුන්නු ගමන් 0.5 මේ මොකක්ද 0.5 නෙමෙයි 0.01 millimeters least count කියලා හිතාගෙන හදන්න එපා. If a different one is given. Right? දැන් එහෙම හදුවොත් ඒකට answer එකක් ඔක තියෙනවා. But that is not the one given. Typical එක ඒක. In our typical micrometer screw gauge, pitch is half millimeter. Whereas this one, it is given as 1. It's given as 1. 6. 6. Out of the following sets of forces, which set can produce a resultant force of 0? We have discussed this type in previous ones also. It's a popular question, popular type. If it produces a 0 resultant, a vector triangle can be drawn. A vector triangle can be drawn. Right? If a triangle to be drawn, right? Geometrically, this should satisfy this. Addition of any two sides should be greater than the third side. Addition of any two sides should be greater than the third side. right? එහෙම නැත්නම් triangle එකක් අඳින්න බෑ. ඒක ටිකක් common pattern එකේ question එක. මේ papers ඒ කියන්නේ මේ paper එකට කලින් paper class එකේම papers දෙකක විතර මේක තිබ්බා. Always you are getting combinations of 3. ඒ කියන්නේ මේ triangle එක use කරන්න තමයි මේ type එක දෙන්නේ ඔය. ඔක common type එකක්. තුනේ combination එකක් ආව ගමන් ටක් ගාලා මේක මතක් වෙන්න ඕනේ. right. check one by one. මම pair wise මේ answer wise යන්නේ. first one. 5 plus 4 කියන්නේ 9. 9 is less than 10 no. triangle එකක් අඳින්න බෑ. It is not 0. Then 2. 2 plus 12 14. It satisfies. හැබැයි අනිත් පැත්තට වෙන්නේ නැහැ නේ. 6 plus 2 8. 8 is less than 12. It should be between any two. Between any two sides. 2 එක අඳින්නත් බෑ. 3. 3 plus 5 8 less than 9. triangle එකක් අඳින්න බෑ. fourth one. 3 plus 5 8 less than 7. ඒක හරි. අනිත් පැය එකත් check කරන්න. 7 plus 3 10. හරි ඒකත් හරි. 4 is correct. 5 එක check කරලා බලන්න. 12 plus 8 20 greater than 3. 3 plus 8 කියන්නේ 11 less than 12. අදින්න බෑනේ. It's 4. Right? Check these conditions. That's it. Because our logic is if it produces a zero resultant, a vector triangle can be drawn. Right? Vector triangle එකක් අදින්න පුළුවන් වෙන්න ඕනේ. මෙහෙම vector triangle එකක් තිබ්බනම් මෙයාගේ resultant එක 0 නේ. Something like this. ඉතින් මේ වගේ triangle එකක් අදින්න පුළුවන් වෙන්න ඕනේ. To draw a triangle, geometrically this should be satisfied. 7. Right. The mechanical arrangement of a merry-go-round is shown in the figure. A is a water wheel of radius 1 meter. Right. මෙතන එක wheel එකක් තියෙනවා. Right. A with radius 1 meter. A with radius 1 meter. B is an axle connected to rotate the merry-go-round. The radius of axle is 0.25 meters. Radius of axle. Axle කියන්නේ මේකනේ. This is 0.25 meters. 0.25 meters. A child hanging from a rope attached to the edge of the merry-go-round moves in a circular path of radius 10 meters. Right. Child කියන එක්කෙනාගේ radius එක තමයි ඒක. හරි. ඒක අපි තියමුකෝ පොඩ්ඩක්. When the water wheel rotates at a rate of 2.5 revolutions per minute. 2.5 revolutions per minute. RPM තමයි දීලා දෙන්නේ. The angle made the rope with horizontal is phi equals 3. Right. So first of all, we have to find V or omega of this axle, because axle is connected to merry-go-round. Merry-go-round is connected to the rope. Rope is connected to the child. Right? දැන් කොහොමද combination එක යන්නේ? මෙන්න මෙතනින් check කරගන්න පුළුවන්. මෙතනින් මේක හොයාගන්න පුළුවන්. If two surfaces are in contact when rotating, their displacements are equal. At the same time, they should rotate the same displacement, same distance. Right? Otherwise, this is not going to align. When displacements are equal, velocities are also equal. Right? Accelerations at these points are also equal. Not omega, but V. Velocity is equal. Omega නෙමෙයි. If two things are connected by a chain, contact by a chain, foot bicycles or any other machines or whatever it is has a chain, velocity through the chain is same. Tangential velocities are same, but omega can be different. Then bicycle එක වදිනවා නම් දැකලා ඇතිනේ. ඒතර bicycle එකේ මොන wheel එකද හයියෙන් කරගෙන? bicycle දන්නේ. foot bicycles. එකක් තියෙනවනේ අර pedals connect කරලා තියෙන එක, it's the larger one. Right? මේ පැත්තේ තියෙන පොඩි එකක්. Right? ඉතින් මේක radius එක අඩු වෙනද මේක හයියෙන් කරගෙන. Right? ඒතර අර what's the benefit? You are pedaling slowly, but rotation of the rear wheel is compared to pedaling wheel, it's faster. Right? ඒතර මෙන්න මේ logic එක දැනගන්න ඕනේ. Velocity at a contacting point. Velocity at contact point. Velocities at contact point are same. Velocities are same. Then we can say V equals V. V equals R omega. Right? Expand this using these two wheels. For first one, V equals R omega. V equals R omega. First one, 1. Omega. Omega is not given, it's given as RPM. Right? For second one, 0.25. Right? Say this omega is omega dash. My target is finding omega dash. So we know omega can be written using RPM as 25 RPM or 60. 25 RPM or 60. Right? Right here. 1 times anything is 1. No? Then omega again 25. 25 is 6. 5 is 3 RPM is 2.5. 2.5 over 60. 6 times 10. 2.5 again 4. Right? Equals 0.25 omega dash. Omega dash equals 0.25 again 1 over 1. Right? Omega dash equals 1. RADS minus 1. Right. Now we know omega of this one. That is 1. Omega is 1. Omega is 1. Now, this child is connected to this wheel. Right? Now he is connected to this. Something like this. When this rotates with 1 radians per second, angular velocity of the entire setup is also same. Angular velocity is same. Velocity change with radius. Angular velocity is same because it rotates the same angle. If the angle is same, angular velocity is same. Right? Then angular velocity of this child is also same. That's the same setup. මේ කට්ටියම එකම angle එකනේ subtend කරන්නේ. Subtended angle at center is same. Omega is theta or t. If the angle is same, omega would be same. Then this is same omega, but this child travels about an external axis. So this is not a rotational motion, this is a circular motion. Right? For the merry-go-round, that is an internal axis, this one. This axis is an internal axis for the merry-go-round. Right? But this axis is an external axis for the child. So that is a circular motion. Right? For any circular motion, for any horizontal circular motion, what we do is considering vertical equilibrium and applying F equals ma towards center. What the angle made with horizontal. Right? Say this is theta. So this is t sine theta. And this becomes t cos theta. Considering the circular motion of this one, apply vertical equilibrium. This is vertical equilibrium. Vertical equilibrium. Considering circular motion. Right? Vertical equilibrium t sine theta equals mg. First one. Right? And then F equals ma towards center. These are the only two things we do for horizontal circular motion. F equals ma towards center. Towards center, we have only t cos theta. Right? A is centripetal acceleration, can be expanded as r omega square. Then radius of circle for this child is 10 meters. Then r is 10, omega squared is 1 square. Omega is 1, no? Right? Then it says t cos theta equals 10m, equation 2. Right? Divide these two. 1 over 2. T to t cancels, tan theta comes. Tan theta equals mg over 10m. M to m cancels. G is also 10. These two also cancels. Tan theta equals 1. Theta equals 45. 3. This is a good combination of rotational motion and circular motion. Right? It's a good combination of rotational motion with circular motion. This wheel, axle, and merry-go-round are rotational motions, and this child is a circular motion. Right? So is there any short methods to find the answer? Short methods කියලා කියන්නේ now if you are comfortable මේක නිකන් හිතලා ගන්න පුළුවන්. right හිතලා ගන්න කියලා කියන්නේ ratio between radii are 1 to 4 නෝ. එතකොට මේක 4 to 1 වෙනවා. එහෙම ගන්න පුළුවන්. ඊට පස්සේ මොකුත් නැහැ. Have to do the circular motion. This is a good calculation, good combination of rotational plus circular motions. And this logic is valid wherever it has a contact with wheels, right? Engines, gear wheels, chains, everything. This is valid. Eight. A block of mass m is placed on top of a wedge of mass 2m, which is inclined at 45 to the horizontal. Right. Inclined at 45 to horizontal. This is kept 2m and m. 2m and m. There is no friction between the block and the wedge. The minimum value of coefficient of friction between wedge and floor to prevent the wedge from moving horizontally when the block slides down is right. So I think I discussed a similar type when I was doing friction. Right? I discussed a similar type. Right? See, since this slides down, method friction one reaction is here. The other reaction on the wedge is this, and mg acts here, simple mg, like this, simple mg, and about the wedge it has its own weight, capital mg, right? It has its own weight, capital mg, right? So if this angle is 45, all angles are 45 no. Angles 45 නම් right angles එක check කරන්න ඕනෙත් නැහැ. All angles are 45. Right? Consider vertical equilibrium. Sorry, perpendicular equilibrium to inclined plane. Consider a perpendicular equilibrium to inclined plane. Then R equals mg cos 45. R equals mg, simple mg, cos 45. R is known. R equals simple mg cos 45. R is known. Right? And there is a component. There is a component of this force which comes as the unbalanced force. See, R sin 45 or R cos 45. Clear? This is the component which comes as the unbalanced force on the wedge. No? Right? Not very unbalanced forces. All forces are vertical. So, when the force component is unbalanced, it causes this to move leftwards. Right? Then friction here should act rightwards. Friction here should act rightwards. Right? Methaniin තමයි reaction එකෙන්නේ. That reaction is not vertical, that is perpendicular to the plane, and one component of that reaction playing the role here to moving this in leftward direction, then friction counteracts in rightward direction. Right? Then to find friction, we need to know the total reaction here. So let's consider this reaction as R dash. Write a vertical equilibrium of system. Write a vertical equilibrium of system. System not bad. Let's write the wedge. This for wedge. Wedge eකට විතරක් ලියමු. vertically upwards, we have R dash. Vertically downwards, capital MG belongs to H. Simple MG is not belongs to H. Simple MG කියන්නේ wedge එක ගන්න නෙමෙයි. Right? ඒක මෙයාගේනේ. මෙන්න මෙයාගේ component එක තමයි wedge එකට එන්නේ. R cos 45 plus R cos 45. Identify the forces. This belongs to wedge. This belongs to wedge. This belongs to wedge. This belongs to wedge. Right? The other two are the forces of simple M. Simplify this. I need to find R dash first to write friction. Then capital Mg plus R cos 45. R is Mg, simple Mg cos 45. Cos 45 is 1 over root 2. Cos 45 is 1 over root 2. Then R dash is capital Mg plus simple Mg over 2. Right. R dash is known. R dash is known. Apply F equals mu R now. To prevent the motion, it should be in a horizontal equilibrium. To prevent the motion, it should be in a horizontal equilibrium. To prevent the motion. Right? Then these two forces of the wedge should be equal. Leftward it has R sin 45. Rightwards only friction. Right? R sin 45. R here R is Mg cos 45. R is Mg cos 45. Mg cos 45 equals F. F is mu R. Mu ne dahanne. Yeah, we need mu. R here is R dash because friction is relevant to the bottom surface. Simple Mg. මෙතන sin 45 එකක් තියෙනවානේ. Sorry. Mg cos 45 times sin 45. R sin 45 නේ. R is Mg cos 45. හරිනේ. R is Mg cos 45. Mg cos 45 times මෙතන තිබ්බ sin 45 එක. Sin 45. Right. Then simple Mg cos 45 times sin 45 is half mu. R dash is here. G is common. Take it out. Then capital M plus capital M නෙමෙයි. What was it? 2m. 2m ne? 2mg. 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 දැන් මේක simplify වෙනවා. 2mg plus mg over 2 කියලා කියන්නේ 5mg over 2. 5mg over 2. Then this is 5m over 2. Right? G2, M2, G2, M cancels, 2 cancels. Mu equals 1 over 5. 1 over 5 again, 0.2. It's 2. Wedge is 2m. Okay. Thank you. 0.2. Friction. And this point is important. Most of you are mistaking here, doing the mistake here. Assuming that R dash is 3mg. No, R dash is not 3mg. R dash is not 3mg. Make a horizontal surface එකේ තිබ්බොත් විතරයි. මේක inclined surface එකනේ තියෙන්නේ. R dash is not 3mg. එහෙම වෙන්නේ නැහැ. ඒක තමයි මෙහෙම හොයාගන්න ඕනේ. That is 5mg over 2. 3mg දැම්මොත් එන answer එක උතන ඇති. If we have inclined surfaces, right, you have to find it with the reaction because reaction changes. Total weight is not acting on this surface now. Only component is acting. That's why it behaves this way. Friction. Nine. 9 is a proved equation, so I'm not going to prove it again, right? I proved in the theory class. Any object leaves when it makes an angle cos inverse 2 over 3. That is a proved value. That's a proved value. The MCQ vector common danangin one. So when I was proving also, I told you keep in mind cos theta equals 2 over 3 and u is greater than or equal to root 5 GL. අපි proofs එකක් කළා. මේ එකක් තියෙන්නේ. cos inverse 2 over 3. It's 3. ඒක ආයි prove කරන්න නැහැ මම. Cos inverse 2 over 3. That's a proved value. Cos inverse 2 over 3. 10. 10. Rain is falling vertically. Water falls onto an open railway wagon moving horizontally at a constant velocity. At a constant velocity. Without friction. Constant velocity without friction, right? Due to the accumulation of water, which of the following quantities of the system decrease? Which of the following quantities decrease? Right. So we know if there are no external unbalanced forces act on the system, linear momentum is a constant. Conservation of linear momentum, right? That is constant. Linear momentum is constant. When water accumulates, mass of the compartment increases. Mass of the wagon increases. When mass increases, velocity decreases because this is a conservation. This is a conservation. If there are no external unbalanced forces, that is when conservation of linear momentum is applicable. Right? Conservation of linear momentum. Then product MV is conserved. Since mass increases, V decreases. V decreases. V decreases. Right? Then momentum. Momentum is constant. Kinetic energy. Kinetic energy check කරන්න ඕනේ. Kinetic energy check කරන්න because velocity and kinetic energy දෙකම තියෙන answer එකක් තියෙනවනේ. තාම ඒතර velocity කියන එක pick කරන්න බෑනේ. Kinetic energy එකට මොකද වෙන්නේ කියලා බලන්න වෙනවා. Right? In kinetic energy both MV changes. Right? Traditional විදියට බලන්න නැතුව මම වෙන විදියක් කියලා දෙන්නම්. See? We know kinetic energy is half mv squared no? To create momentum here. Momentum කියන්නේ constant එකක් නේ. ඒතකොට ඒක හදාගත්තම ලේසි. දැන් graph එහෙම කරලානේ තියෙන්නේ. මෙහෙම ලියව කියලා අවුලක් නැහැ. Reshaping. හරි? Reshape කරගන්න පුළුවන් නේ. Because my intention is creating momentum here. mv is momentum, then m squared v squared is p squared. එහෙනම් මට මේකට මෙහෙම දාන්න පුළුවන් නේද? Equals this is p squared over 2m. ඒතකොට ලේසි. නැත්තම් මෙතන variables දෙකක් ඉන්නකොට ආගිව් කරන්න අමාරුයි. mass එක increase වෙනවා, velocity එක decrease වෙනවා. right? ඒතකොට දැන් මේ දෙකම variable තියෙද්දි හිතා ගන්න අමාරු වෙන්නේ. එකක් constant තියාගත්තා නම් ලේසි. Then this is a constant. When mass increases over time, kinetic energy still decreases. So answer is 5. Velocity and kinetic energy 5. if you can keep this in mind as an equation, it's useful, right? Past papers අරන් බලන්න මේකෙන් කරන්න ඕනේ questions ඇවිල්ලා තියෙනවා හතරක් විතර. ඒ කියන්නේ if mass is doubled, kinetic energy is halved. ඔහොම කීකේ statements දෙනවා. Momentum is unchanged. නැත්නම් when momentum is doubled, kinetic energy is doubled. එහෙම කියලා දෙනවා. එහෙම දුන්නාට පස්සේ මේකෙන් check කරන්න ලේසි. Right? Okay. That's it. Then let's start next 10 questions. 11 to 20. 11 to 20. 752. Hmm. 15 minutes. Ask if any questions. 17 is correct. It's correct. Values are correct. Right. 11. Angular displacement theta is given by theta equals k alpha t squared. If alpha is angular acceleration and t is time, the dimensions of k is 11. Theta equals k alpha t squared. Theta equals k alpha t squared. Right. Theta is angular displacement. That is an angle. Angles are dimensionless. Right. Dimensionless means for calculations we use 1. I need dimensions of k. Dimensions of alpha. Angular acceleration we proved in the class t minus 2. Substitute karna t minus 2. Right. And t squared. These two cancels, which means k becomes 1. K is dimensionless. K is dimensionless. No dimensions. 5. For 11, it's 5. 12. Graphing. 12 is all about graphing. Omega with f. Centripetal acceleration of a particle which is moving in a circular path with uniform angular velocity of omega is f. Centripetal acceleration. Right? The graph between omega and f. Centripetal acceleration. Equation of centripetal acceleration is a equals r omega squared. A is given as f here. F equals r omega squared. Right? Subject omega because omega is at y. Then omega squared is f over. Omega squared is f over. Omega is, isolate these terms, root r, root f. Right? F is x, but this is root x. Whatever it is as a product with x is gradient. This is y. Y equals m root x. A standard curve. Y equals m root x. 3. Graphing 7 again the. And again, මේ shape එක ගන්නද ඉතින් මේ equation එක හදලා ඒ shape එක හොයාගන්න ඕනේ. Right? 13. 13. A cricket ball leaves a bat after striking at an upward angle of 30 to horizontal with a velocity of 60. The ball lands on a roof of a building as shown in the figure. If the flight time taken to land on the roof is 5 seconds, height of the building is right. Then we can apply S equals ut plus half t squared upwards at once. Right. S equals ut plus half t squared upwards. S is h. Vertical height. U is not 60, that is 60 sin 30. 60 sin 30. T 5 seconds plus half. We are applying upwards, so this is minus 10, right? T squared, 5 squared. H equals sin 30 is half. 30 times 5 minus 5 times 25. H equals 150 minus 125, 25 meters. 25 meters 3. Take a lazy, a normal projectile motion question. Very normal one. Projectile motion is also a normal one. Fourteen. A box of mass 5 kg is kept on a horizontal surface. A box of mass 5 kg is kept on a horizontal surface. The coefficient of static friction between the surface and the box is 0.3. Okay, box of 5 kg. Then 50 newtons, 50 newtons R, right? Mu is given 0.3. If a horizontal force of 10 newtons is applied on the box, the frictional force acts on the box is, right, 10 newtons is applied. Then with this moving tendency, friction acts opposite to this F, right? First you can find the value of limiting friction. F equals mu R. Mu is 0.3, R is 50. It says 15 newtons, right? What the hell then? Frictional force acting on the box is 15, not 15. 15, no. This is the limiting friction. This is the limiting friction, right? Maybe limiting friction. Applied force is only 10, which means it is still in the self-adjustment region, right? Then I will make mark and not. You have got this value now. This is 15 newtons, right? Applied force is less than 15. It is only 10. It is only 10, which means this 10 is counterbalanced by friction, because up to 15 that is adjustable. Up to 15 that is adjustable. That was the exact meaning of self-adjustment region. Then when the applied force is 10, frictional force is also adjusted to 10. Answer is 10. 4. For 14, it's 4. Right? Class එක අපි ඔගෙන් discuss කරා. Tutor questions තිබ්බා. mu r දාලා 15 ගහන්න එපා, because ඒකෙන් එන්නේ limiting point එක විතරයි. ඔයා check කරගන්න ඕනේ යා self adjustment region එකේද කියලා. මේ කොහොමත් friction එකේ එච්චර ලේසියෙන් answer එක આવොත් ගොඩක් එහාට වැරදි ඇති. එහෙම වෙන්නේ නැහැ. ඒ කියන්නේ නිකන් f එකයි r එකයි දීලා mu අහන්න හරි mu එකයි r එකයි දීලා f අහන්න හරි එහෙම එන්නේ නැහැ ඉතින් මේ level friction question එක. වාක්කරයේ thinking part එකක් තියෙනවානේ. ගොඩක් වෙලාවට ඒක මේ මෙතනට තමයි link කරන්නේ. self adjustment එකට. 15. As shown in the figure, a fireball displayer of a precision curls a fireball on a horizontal circular path of a radius r1 with a uniform angular velocity omega1. If he shortens the radius of the path to r2 without applying an external torque, the new angular velocity of the ball is, right? If there is no external torque, angular momentum is conserved, right? If there is no external torque, angular momentum is conserved, right? Angular momentum is conserved. Angular momentum is conserved, which means I1 omega 1 equals I2 omega 2. Angular momentum is conserved, right? I1, I can be written as mr squared about an external axis, right? Then fireball rotates about an external axis, no? Mr squared, then mr1 squared, omega 1. I2, same mass of the fireball, but radius is different, r2 squared, omega 2. M cancels, that's it. Simplify this. Omega 2 equals omega 1 r1 over r2 squared. Omega 1 second. That's also easy. Angular momentum. 16. 16. 3 different liquids with densities ρ1, ρ2 and ρ3 are poured into a U-shaped container as shown in the diagram. Which of the following equations gives the correct relation between the densities of liquids in the container, right? 15 and 10. This height is 15, right? Okay, if this is 10, this part is only 5 centimeters, right? There are two interfaces of the liquid here. There are two interfaces. One interface is here. Any point where two liquids meet each other. Interface can two liquids meet each other is an interface. So this is an interface. This is also an interface, right? Pressures at same horizontal level of the same unbroken liquid, same consistent liquid are equal, right? If you are to consider this interface, see, if you are to consider this interface, this level, if you are to consider this level, at this interface, right here, at this interface, you have rho 2 and rho 3 liquids. But here we have rho 1. That's not the same liquid, so this cannot be used, right? If you consider this interface, here we have the liquids rho 1 and rho 2, and here you have rho 2. Then rho 2 is unbroken. This can be considered, right? Then let's say these points are A and B. Hydrostatic pressure. Pressure at A equals pressure at B, right? Pressure at A equals pressure at B, right? The theory is pressures at same horizontal level of the same unbroken liquid are equal, right? Same liquid එක විතරයි equal වෙන්නේ. U-tubes, right? අපි U-tubes වල මේක discuss කරා. U-tubes. Right, then TA equals PV නේ. ඒක check කරලා බලන්න. This is open to atmosphere. Atmospheric pressure acts P naught. This is also open to atmosphere. P naught acts. Right? Hydrostatic pressure is H rho G. So this is P naught plus H is 15 rho 1 G. From the other limb, P naught plus H 10 rho 2 G 5 rho 3 G. Hydrostatic pressure is H rho G. Right? G to G cancels. Last line on. Right. Then simplify this 3 rho 1 equals 2 rho 2 plus rho 3. 3 rho 1 equals 2 rho 2 plus rho 3. Rho 2 rho 3 rho 3 කියන්නේ මේක sorry මේක තමයි rho 3. This is given as rho 3. I thought it's rho 2. මේක rho 2. Let us make a change now. This is rho 3 now and this is rho 2 now. Rho 2 rho 3. There are 3 rho 1 equals 2 rho 3 plus rho 2. First one. $17. Right, 17. Specifications. A washing machine is operated with a motor 320 watts and the rotating disc of it has moment of inertia 5 kgm squared. Right? Kgm squared කියලා දෙන්නේ, not 2 kgm squared. Kgm squared. Starting from rest, how long will it take to acquire a frequency of 240 rpm under the above power? Pi squared equals 10. Right. Then omega should be acquired is 25 rpm or 60. No? Omega is 25 rpm or 60. Then 25 rpm is 240 over 60. 60 times 4. Omega is 85. Omega is 85. Right? And power is given. Power is given. Then we know P equals Fe in linear motion. P equals Fe. What is the rotational version of P equals Fe? අපි equation conversions වලදීත් මම කිව්වා. දැන් ඒවා use කරන්න හදන්නේ. P equals Fe, P equals torque omega. Right? P equals Fe එකේ rotational version එක. Power equals torque omega. Power equals torque omega. Power is 320 now. right? Torque omega is 8.5. අපි torque එක expand කරන්න දන්නවනේ කොහොමද? Torque equals I alpha. I is given. Torque equals I alpha. I is given. Then 320 equals torque is I alpha 5 alpha. 5 alpha 85. 5 alpha 85. Right. මෙතනින් alpha එක හොයාගන්න පුළුවන්. 8 times 5 කියන්නේ 40. 40 කියලා කියන්නේ 8 නේ. Right. මේ දෙන්නේ 8. Then alpha is 8 over 5. Alpha is 8 over 5. Right. All then what the time measure. Then apply a motion equation. Final omega is known and it is starting from rest. Initial omega is also known. Right. Alpha is known. Time is to be determined. V equals u plus at. Then the rotational version. Omega 2 equals omega 1 plus alpha t. Right. Omega 2 equals omega 2 equals omega 1 plus alpha t. Omega 2 is omega 2 omega 8.5. 8.5. Omega 1 is 0 starting from rest. Alpha 8 over 5. 8 over 5 t. Right. Then 8 to 8 cancels. T equals 5 squared. 5 squared can 10 kilo. T equals 10. T equals 10. 17 5. See, everything is done using rotational motion equations, right? Okkoma rotational motion equations. Everything is done using rotational motion equations. Rotational motion equations. Right. 18. 18. 18. 18. Consider the following statements made about forces. A force is needed to keep an object moving. Right. And yeah, the force is needed to keep an object moving. True or false? No. Why? Newton's first law. Newton's first law. Right? If there's no unbalanced force acting on an object, it is either at rest or moving with the uniform velocity. Right? I think uniform velocity can force no force is required to move with the uniform velocity. Then A is wrong. The force is needed to keep an object moving. Wrong. Because it can travel in uniform velocity without a force. It can travel in uniform velocity without a force. Newton's first law. Newton's first law. B. When a ball has been thrown, the force exerted by the hand on the ball remains with the ball. When the ball has been thrown, the force exerted by hand on the ball remains with the ball. Yes or no? Huh? The ball is thrown vertically upwards. The ball is thrown vertically upwards. Force applied by the hand on the ball remains with the ball. As soon as the contact is lost, the force is no more. The force is contact area. So when it is moving here, that is moving under gravity with mg. May force right? Contact force. Until you have the contact, the force remains. When the ball has been thrown, be strong. As soon as the contact is lost, the force becomes 0. As soon as the contact is lost, the force becomes 0. Right. See, the product of mass into acceleration is not considered as a force. The product of mass times acceleration is not considered as a force. It is correct. It is correct. Why? force කියලා කියන්නේ not mass into acceleration. Dimensions එක තමයි. But force is mv minus mu over t. Rate of change of linear momentum is considered as a force. That's a definition. A definition එකෙන් තමයි මේ question එක අහන්නේ. සක්කාල එක ඇද්දි තේරෙන්න ඕනේ. That is from the definition. Definition of external unbalanced force. Rate of change of linear momentum. Rate of change of linear momentum. It's correct. So only C. 18.3. 19. 19. A boat travels at a uniform velocity of 10 ms minus 1. The resistive force against the motion of the boat is 400 newtons. Resistive force. The power of the engine of the boat. Right. Now, if this is the boat, right, and the resistive force acts on the boat is 400 newtons. The minimum traction force, to be given by the engine is also 400. Minimum. For any force which is greater than 400, it travels. Uniform, that's uniform. Uniform means force is exactly 400 because there's no acceleration for the system. It's given as uniform, right? It's given as uniform. Then F equals 400. F equals 400. We know P equals Fe. Rotational equation use kara. P equals torque omega. P equals Fe. Linear version. Right? Power is asked. Then this is the traction force, right? Traction force is 400 into velocity 10. 4,000 watts. 4,000 watts. මේක තමයි ලේසිම ගාන මෙච්චරලා තිබ්බා. අතරම. හදන්න ඕනේ නැහැ. 20. 20. A ball moving on a smooth horizontal plane at a uniform velocity collides against a vertical stationary wall. Right. A ball moving with a uniform velocity like this collides against against a vertical stationary wall and bounces back perpendicularly to the wall. Right. Collides with this velocity and it bounces back. If the collision is elastic, if the collision is elastic, what is an elastic collision? Elastic. If there's no energy loss due to a collision, there is an elastic collision, right? No energy loss. If no energy loss, what can we say about velocities? Kinetic energy is same, then velocities are same. If it is collided with V, it bounces back with same V because no energy loss. Kinetic energy remains same. Since mass is same, velocities are same. No energy loss. The graph between the speed of the ball and time is right. Speed and time. Right. More than 5, 3, 5. 5 නෙමෙයි. Why? This is speed time. Speed is a scalar. 5 එකේ තියෙන මොකද්ද? Velocity time. 5 එකේ තියෙන velocity time and ඒක elastic එක නෑ. ඒක elastic එකක් නෑ. If it was elastic, value should be same, no? Right? ඉතින් speed time ඉඳලා vector sign කරලා දාන්න. ඒතර 4 කියන answer එකයි 5 කියන answer එකයි කොහොමද වෙන්න බෑ. That is velocity time. Speed නේ අහලා තියෙන්නේ. Answer is 3. Velocity is unchanged, so speed is unchanged. Answer is 3. Speed එකට ඉතින් direction එක ගන්න නැහැ. Any scalar is on the same side only. Scalar එකට direction එක ගන්න නැහැ. There's no signage. There's no signage for a scalar. Speed නේ අහලා තියෙන්නේ. Not velocity. Right? Then if you need more clarity, මේක තමයි මෙයාගේ speed time. මේක තමයි මෙයාගේ velocity time. This is how it should be. Right? Speed time and velocity time. Accelerations තියෙනවත් ඔක්කොම ටික අයින් කරලා දාන්න. Velocity is uniform velocity, it says. Right. Then you can start the next 10, 21 to 30. 34. I couldn't tell you මේ අද තියෙනවා pink moon කියලා එකක්. දැක්ක? දැන් මට එළියට ගියා මතක් කරේ. ඒකට පේන්නේ නැහැ, it's cloudy today. මේ සමහර travel ආ clear වුණොත් වෙයි පෙන්නොත් බලන්න. මේ pink moon කියලා එකක් තියෙනවා. Like blood moon. Today we have something called pink moon. ඒ කියන්නේ ඒක refraction වලින් වෙන්නේ. physics තමයි. මේ pink කියලා එකක් තියෙනවා. දැක්කොත් බලන්න. pink moon. ඔයගේ මොකක් හරි තියලා දාලා ගොඩක් වෙලාවට අපිට ඔක පේන්නේ නැහැ ක්ලවුඩි. දැන් අදත් එහෙම වෙලා තියෙන්නේ. 25th. It's correct. It's correct. Right. Okay. 21. An object of 2 kilograms is kept on a rough plane with an inclined, which is inclined at 30 degrees to horizontal, as shown in the figure. The object is fixed at a point at the top of plane by a light inextensible string parallel to the plane. If the coefficient of friction between the inclined plane and the object is root 3 over 2, the tension of the string is, right, a friction 1 again, right. Let's say tension is T and mg angle is 30, mg can 20 newtons. This is 30. Then this is mg sine 30. 20 sine 30 is 10 newtons. 20 sine 30, 10 newtons. This component is 20 cos 30, right? 10 root 3 newtons. Reaction R, right? Tension of the string, right? So first of all, we have to check friction. Moving tendency should be downwards, no? Then friction is upwards. Once you apply F equals mu R, always what you get is limiting friction. So this is limiting friction, right? Limiting friction, mu is given as root 3 over 2, R equals 10 root 3. R equals 10 root 3. R equals 10 root 3. Perpendicular equilibrium to inclined plane, right? 5 again, we think 15 here, 15 newtons, right? What has happened now? Moving tendency was 10 newtons, right? Moving tendency was 10 newtons. Now moving tendency create because that is upwards. This creates a moving tendency of 10 newtons, whereas the maximum friction, limiting friction, which can go up to is 15, right? Which means friction is still at the self-adjustment region. Friction is still at the self-adjustment region. So friction is adjusted to 10 newtons. When friction is adjusted to 10 newtons, tension is 0. Tension not nada. Tension ne go when friction ne kada tallang in very run. Then friction ne balance ka lega. That's the meaning. Our calling go away. 15. But the moving tendency is only 10. Moving tendency is only 10. So therefore, actual friction which acts here is, this is Fs, limiting friction. Actual friction which acts here is 10 newtons. Then 10 newtons of friction to 10 newtons here are balanced already. So T is 0. T is 0. A tricky question, no? A tricky one. 21, 0. For 21, it's 0. What's the meaning? May string ke method kya again no? If we cut the string from here, still this remains unchanged. Friction ne balance kar lo tension na kadanna. Then the string code na. Because friction can do this up to 15 newtons, right? Up until 15 newtons. Friction can handle this alone up to 15 newtons. Okay. The corresponding displacement time graph for the given VD. Right? Okay. Not a new type, a very popular question. Like gradient of ST. Gradient of ST gives velocity. Now velocity is known, then you can find gradient of ST. Velocity is known. Check the behavior of velocity. Check the behavior of velocity. Right? Behavior of velocity. What's the sign? Plus or minus? Minus. And magnitude? Magnitude again unchanged, increasing or decreasing? Magnitude decreases. Magnitude decreases. Right? Sign is minus, magnitude decreases. Behavior of velocity. Behavior of velocity should be the gradient of st. This velocity is positive and its value increases, positively increasing. This velocity is positive, its value is constant. This velocity is positive, its value decreases. Right? And my gradients positively decreasing. Negative decreasing. Negative decreasing shape. Negative decreasing. Then positive increasing. Shape. Positive constant. Linear. Positive decreasing. Third one, right? Third. Yeah, thirdly. Oh, third. For 22, 3. A backward conversion. $23. 23. A ladder is in equilibrium on a vertical plane which is perpendicular to the wall, as shown in the figure below. Vertical plane perpendicular to the wall. All right. One end of the ladder is on rough horizontal ground, and the other end is resting against a smooth vertical ground. Right. Make rough. This is rough, and this one is smooth. This is ladder. Then the correct free body diagram for the forces acting on the ladder is which of the following statements? Statements. Right, it should be which force diagram is, the correct free body diagram for the forces acting on ladder is, that's it. Cut off the rest. Right, clear now? Okay, this is a smooth wall. Then here we have reaction from the wall that is perpendicular to the wall, say R1, and mg acts at the center of gravity. It's a uniform ladder, right? mg acts at center of gravity. mg acts at center of gravity. And here, perpendicular reaction acts R2, and moving tendency of this end is leftwards. Right? Slip in, then friction is rightwards. Right? Okay, in all diagrams given, only 3 forces are given, which means a resultant is considered here. Take a iron load. අපි හොඳටම දන්නවනේ forces හතරක් වෙන දෙනවා කියලා. ඉතින් 4 ඒවා දීලා නැහැ. So resultant is given instead. එතකොටනේ හතරක් තුනට අඩු කරගන්න පුළුවන්. Resultant එකක් දීලා තියෙන්නේ. කාගේ resultant එකද? මේ දෙන්නයි. R2 and F. Right? We know this. We know this. If an object is under equilibrium under 3 non-parallel forces, all 3 forces should be what the first teacher. All 3 forces are concentric, intersecting at the same point. Right? Resultant that resultant goes through this point. Then only it can be concentric at this point. Right? Barney theory is useful. Then resultant of these two should go to this point intersection. Right? मैं वगैरह diagram में आपको theory class से कितना दिला right? मैं लड़ेगा कंधा. Right? මොකද එතන match වෙන්නේ 4 හරිනේ. එතන තියෙන forces තුන මේ තුන mg resultant of R2 and F with R1. It's 4. For 23 it's 4. $24. A person traveling in a car is holding a cylindrical cup of tea vertically as shown in the figure. Neglecting the vibration of the car, what's the maximum acceleration that the car can go without spilling any tea? Right. Accelerating liquid containers. Accelerating liquid containers. 3 and 4. Right. 3 centimeters. T T is filled up to 3 centimeters. This is 1. Then at the maximum acceleration, this is how this T surface should be. Initially it was like this, right? Initially it was like this. So when this goes up by 1 centimeter from this side, it goes down by 1 centimeter from the other side. Then this should be 2 centimeters. And this is 4 centimeters altogether, right? This is still 3 centimeters, right? This is called the angle of inclination when accelerating a liquid. Angle of inclination, right? Modal in acceleration of car, right? This is a proved equation. Tan theta is A over G. Tan theta is A over G, right? For an accelerating liquid. Tan theta can be written using the triangle. This is method 2 ne 2 kilo again 1 2 ne again 2. Tan theta is 2 over 3 A over G. Then A equals 2G over 3. 2G over 3, right? 2G over 3. Divide करने दिला दे 2G over 3 के लिए क्या है G over 1.5. G over 1.5. G over 1.5. 3. Right? Accelerating liquid containers. Right? How can tan theta is A over G? It was done, I think, 3rd week of March. 3rd or 2nd week of March or 3rd week of March. Maybe 2nd week of March. Yeah, second it should be. 25. This is a proved equation for any liquid container. Tan theta equals A over G when accelerating. 25. The period of simple pendulum hung on the roof of a vehicle is T when it is moving with a uniform velocity of 40 ms minus 1. As shown in diagram, the vehicle then enters a bridge with a curved surface of radius 320 meters with the same speed. When the vehicle reaches the highest position of the bridge, the new period of pendulum is given by. Diagram is not to the scale. Right. Period of a pendulum equals 25 root L over G. Right. Where G is resultant acceleration. Resultant acceleration. Right. So when it undergoes a circular motion, centripetal acceleration comes. Then we have to find the centripetal acceleration first. That is R, V is given. Then V squared dou R. R omega squared, V equals R omega. So that is V squared dou R. Right? V squared is 40 squared. 40 times 40 over R 320. 0 to 0 cancels. 4 times 8. A equals 5. Centripetal acceleration is 5. Centripetal acceleration acts towards center. Centripetal acceleration acts towards center. Then, when it undergoes in circular motion, right? Simple G acts because of the gravitational field and A acts towards center because of the circular motion, right? Then new acceleration is known. New acceleration is known. For first scenario, that is T, right? Yeah, that is T. That is T for first scenario. T equals 25 root L over G. G is 10. G is 10 for the first scenario. For second scenario, T dash equals 25 root L over 10 plus G, 10 plus 5, 10 plus 5, G plus A, right? G plus A, 10 plus 5, 15. Divide these two. Divide these two. T dash over T, T dash over T equals 25 cancels, right? Then T dash root L over 15. And this is root 10 over L. Root 10 over L, right? L to L cancels. 10 and 15 again 2 over 3. Then 2 over 3. T dash T. Root 2 over 3T. Root 2 over 3T. Second one. $26. The diagram shows the distance time graph for a moving object. Which statement is most suitable? Displacement time. Right. So by the way, what's the difference between these two? 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 Huh? Rest again. මේ ST එකක් දීලා තියෙන්නේ. නෝට VT. What's the difference? නැත්නම් මේ දෙක same ද? අර පොඩි කාලේ වගේ අර එන්නේ differences හොයන්න කියලා එහෙම නේද? මේ ST තියෙන්නේ. ST තියෙන්නේ. This is the difference. What is given by gradient of ST? Gradient of ST is velocity, right? Gradient කියන්නේ මොකද්ද? Tan theta. Gradient is tan theta or delta y or delta x. Tan theta, right? Now this has an initial angle. This has an initial angle, non-zero angle, right? Which means it's a non-zero tan theta, non-zero gradient, non-zero velocity. So this is starting with an initial velocity. Starting like an initial gradient at zero, there is a non-zero initial gradient. But here there's zero initial angle, then no gradient. This starts with it starts from rest, not a velocity, not with the velocity, from rest. Right? Tan theta can check karan. That's the difference. Both are accelerating. If you need to check initial velocity, check initial gradient, because velocity is given by the gradient. Right? Okay, point. A motion with uniform velocity. No, it is accelerating. Come check karan. Check kalabaan angles. What happens to the gradient here? May positively increasing gradient again. Gradient increases over time. When gradient increases, velocity increases. Velocity increases means it is accelerating. Velocity increases, it is accelerating. Right? Anna? Angle increases, positively increasing gradient. Natta angle check karanna. Right? Angle increases. Then when angle increases, gradient increases. Gradient increases means velocity increases. Increasing velocity is an acceleration. Right? Motion with uniform velocity, wrong. A motion with uniform acceleration. A motion with uniform acceleration. It's correct. But we don't know whether it's uniform or not. It's an acceleration. A motion in acceleration with starting at rest. Rest name non-zero. A motion with deceleration, no. A motion in acceleration with initial velocity, 5. It's 5. $27. Right? Make point. This is the point. If you need to check initial velocity of a ST, check initial gradient. If you need to check initial velocity of a ST, check initial gradient. Because velocity is given by gradient. Right? $27. 27. The diagram shows two hammers which are equal in shape. Handle of the hammer P is made up of metal and handle of the hammer Q is wooden. Q is wooden. Mass of two hammers are equal. Out of the given statements, which statement shows the correct hammer? Right? Correct means a proper one, proper hammer, and the place that it should be held in hammering a nail. Okay. What's the physics behind this? What's the physics behind hammering a nail? Huh? What's the principle of physics, right? We use when hammering a nail. Listen. What's the principle we use when hammering a nail? What's the principle of a hammer? Principle of a hammer. දැන් ඒක තේරුම් නැත්නම් approach එක මොකක්ද කියලා තේරෙන එකක් නෑ ඒක වාට. What's the principle? ඔව් දැන් මෙහෙම කර බලනවා මොකක්ද කියලා කියන්නේ. ඒක තමයි. දැන් මේ මොකද්ද? What's the principle? Force moments. Right? Force moments. We are using force moments when hammering a nail. Right? මෙහෙමනේ ඉතින්. ඉතින් මේ point එකේ නම් මෙතන perpendicular distance එකක් තියෙනවා. And what creates a force moment here? Natural force moment is created by mg, weight of hammer. Right? Additional එකක් අපි දානවා. Right? ඒ කියන්නේ our effort is something additional. කොහොමද natural force moment එකක් තියෙනවනේ. හැම එක මෙහෙම තියන් හිටියත් මේක naturally මෙහෙම වැටෙනවනේ. That's a natural force moment. So difference between these two is now this one is made of metal. This one is made of metal. This one is made of wood. Wood should be lighter than metal. It is a lighter material. Then in this hammer, look at here. In this hammer, this side is much heavier compared to the handle. This side is heavier. Always center of gravity displaces towards heavier side. Then center of gravity of this hammer is somewhere close to this. Compared to this one, center of gravity of this one is to the right of this point because this is a metal. Then both are heavy. Compared to this side, this is much lighter. And heavy side මේ පැත්ත. එහෙනම් මෙයා මෙහෙට shift වෙලා තියෙනවා. Right? Now, principle when hammering a nail is force moments. Force moment is given by force into perpendicular distance. Right? Masses are same. It's given. Which means mg are same. Now, if you can grab this as maximum d is satisfied, then it creates a naturally higher force moment. Right? Then it makes us easier to hammer it. Right? Then ගෙදර හැම එකක් තියෙනවා නම් මේ හැරෙන් අල්ලගෙන try කරලා බලන්න. ගන්න බෑ. ඔව්. ඒක තමයි හැටි. දැන් එහෙම ඉතලත් ඉතින් එන ගහලා තියෙන කෙට්ටත් ඕකට ආන්සර් එක ගන්න පුළුවන් වෙයි. ඔය එහෙමත් පුළුවන්. හැබැයි මෙහෙමයි. මෙටල් එකකුත් යූස් කරලා තියෙනවා නම් ඒ ඩිෆරන්ස් එක තේරෙනවා. ඒක හොඳට තේරෙනවා. රයිට්. දැන් අපේ ගෙදර දෙකම තියෙනවා. එතකොට දැන් මම ෆිසික්ස් උත් දන්නවනේ. ඒතර කොහොමද තේරෙනවා? මේ ඒක නැතත් ඒක තේරෙනවා. අර මෙටල් එකකින් ගැහුවොත් durability is there. But the disadvantage is we have to put more effort by our own. අර wood එක එහෙම නෙමෙයි. ඒක නිකම්ම යනවා හොඳ force moment එකක් එක්ක. ඒතර අපි අතින් තේරෙන්න ඕනේ පොඩි effort එකක්. That's better. ඉතින් අන ගහනවා නම් we should be able to do it over time with less fatigue no. ඕකනේ ඔගේ purpose එක. ඉතින් මේක තමයි හොඳ එක. And principle of force moments, higher the perpendicular distance, higher the natural force moment. තොර මේ හැම එක මෙන්න මේ හරියෙන් grab කරා නම් that's the best case. Right? දැන් grab කරනවා කියලා මේක මේ හරිය අයිනෙම මෙහෙමල් ලගෙන ගන්න බෑ. හොඳද? ඊට පස්සේ ඇඟිලිත් තරහාගෙන එන්න වෙන්නේ. එහෙම නෙමෙයි. The maximum possible length, maximum possible distance. Right? Okay, then අර දැන් ඒ වගේ පොයින්ට් එකක් කොහොමත් ගන්න බෑ. ඒ වගේ එකක් දීලා තියෙන මේ හරිය. මේක center of gravity වගේ. ඒක center of gravity එක උනොත් අදිස්සිය හරිය. There's no force moment at all. ඒතර එකක් ගහන්න බෑ. If you grab it from the center of gravity. Right? ඒක unbalanced වෙනවා. Okay, then correct hammer is Q at point B. 5. Q at point B. Principle එක තියෙන්නේ මෙතන. Force moments. Force moments. Force moments. ඇණයක් ගැහුවත් ඉතින් physics තමයි. And something adding to this, longer the length, higher the length of the handle, much easier, much convenient it to hammer something, right? අර එහෙම කියලා ගොඩාක් දිගට අපි ඉතින් ගන්න නැහැ handle ගන්නත් ලේසි වෙන්න බෑ. Comparatively, if you have a higher length, right, it is more convenient. 28. ඔය principle එකම use කරලා තව ඒවා තියෙනවා. මොනවද? force moments use කරන tools තව අපි use කරනවා. force moments use කරන ගොඩක් tools වල. ගත්ත? what? ඔව් ඒකත් හරි. ඒ කියන්නේ ඒක හැමමනේ. ඒක හැමමනේ දැන් ඒ කුළු ගෙඩිය කියන එකට එහෙම අපි metal වලින් ගහලා තිබ්බොත් එහෙම මිටක් ඒක සෑහෙන disadvantage එකක්. ඒ කියන්නේ ඒක ලොකු force එකකින් කරගන්න ඕනේ වැඩක් නේ. මේව නම් ඒ හින්දා woodමයි ගහන්නේ. කොහොම හරි ඒක උස්සගත්තා නම් ඇති. Because it has a very higher weight, then it comes down naturally with this higher force moment. ඒක MG එක ගොඩක් වැඩි. දන්නවනේ අර මේවා කරන්න තියෙන්නේ. Even knives, right? ඔය knives වල දැන් family එකක්ම ඉන්නවනේ range එකක්ම තියෙන්නේ. ඒ ඔක්කොම ටික හරි. ඒ ඔක්කොම force moments තියෙන්නේ. Swords, right? ඒ family එකේ ඉන්න ඔක්කොම ටික හරි. කැපෙන ඒවා ටික සේරම හරියනවා. කැපිද පොරවල්ද ඔක්කොම. හරි? ඔක්කොම tools ගොඩක් තියෙනවද? මේක හිතලා බලන්න. අපි මෙහෙම කරලා වැඩ කරන ඒවා තියෙන්නේ. අර කියන්නේ force moments එකක් එක උදැල්ලා හරි යෝ. උදැල්ලා හරි. shovel නෑ. ඒක වෙන එකනේ. ඊට පස්සේ අර දැන් ගස් කපන ඊට පස්සේ ආරම්භණන් ඔය තියෙන්නේ. කියන්නේ අර knife family එකේ කට්ටිය. hydraulic jack? hydraulic jack නෑ. hydraulic jack එකේ තියෙන්නේ Pascal principle, hydrostatics. හරි ඒක මම තාම කියලා දුන්නේ නැහැ. Pascal's principle. hydraulic jack එකේ නෑ. hydraulic jack for vehicles? Nah. That is called Pascal's principle. Pascal's principle. Right. හරි මේ ඉතින් මතක් කරලා බලන්න මේ වගේ ගොඩක් තියෙනවා හොඳ tools. There are day to day tools we use. Right, where we use force movements. There are පොරව කියලා කියන්නේ පොරවට කියන term එක නම් මම දන්නේ මොකද කියන්නේ ඒ term එකක් තියෙනවා. පොරව කියන්නේ x නේ. ඔව්. පොරවට නෙමෙයි කැත්තර කියනවා. හරි x ගමුකෝ. ඒකත් මතක් වුණානේ. x එක තියෙනවනේ. x කියන්නේ මෙන්න මේක. හරිම x එක මේකනේ. මෙහෙම දෙපැත්තටම තියෙන්න ඕනේ. ඔන්න ඕකනේ හරිම x එක. හරි මොකක් හරි. මෙහෙම එක තියෙනවනේ. right. මේකක් ගෙදර තියෙනවා නම් කරලා බලන්න මේ හරියෙන් වගේ අල්ලලා ගහන්න ගියොත් තමයි ඔයාට ඒ ගන්න අර කියන්නේ ස්ට්‍රෙන්ත් එක ගන්න බෑ. හරි මෙහෙන් අල්ලලා ගන්න you can gain a higher strength, higher force moment, then much easier to cut something. Right? Okay, that's enough. 28. 28. අර knife range එක කියන්නේ මෙහෙමයි මේ මොනවද දැන් අර බටර් knife වගේ ඒවා ඉන්නේ නැහැ හොඳේ දැන් ඒකේ මෙහෙම කරලා ගහන්නේ නැහැ නේ බටර් වලට ඒ force movements තියෙන්න ඕන knife කියලා කිව්වට පස්සේ ඉතින් ඒක තේරෙනවනේ බටර් knife එකේ ඉන්නේ නැහැ ඉතින් ඊට පස්සේ අර bread knife එකේ ඉන්නේ නැහැ bread වලට මෙහෙම ගහන්නේ නැහැ අර think of the use case 16 newtons 30 30 5 30 5 30 5 30 12 root 3 8 8 12 root 3 right 1 2 3 4 5 ne there are 5 forces 1 2 3 4 5 හරි see cancel වෙනකොට අග්ගල වෙන්න ඕනේ listen cancel වෙනවා ඒවා ඉතින් මුලින්ම වෙන්න ඕනේ this is 5 sin 30 මේ direction එක වෙනවනේ 5 sin 30 acting upwards this is 5 sin 30 acting downwards right then these two components cancel each other 5 sin 30 to 5 sin 30 cancels upwards එකක් වෙනවා downwards එකක් වෙනවා right ඊට පස්සේ මේ දෙක ඇඩ් වෙනවා 5 cos 30 5 cos 30 මේ දෙක ඇඩ් වෙනවා මම එනම් මේ පැත්තට ලියා ගන්නවා 5 cos 30 plus 5 cos 30 is 10 cos 30 right 10 cos 30 plus 12 මෙන්න මෙහෙමක් එනවා 10 cos 30 plus 12 root 3 හරිද horizontal එක විතරක් simplify කරලා බලමු this is 16 cos 30 16 cos 30 in this direction 16 cos 30 cos 30 is root 3 over 2 so this is 8 root 3 right and this is 5 root 3 එතන මේ පැත්තට ඇවිල්ලා තියෙන්නේ මොකද 12 root 3 plus 5 root 3 17 root 3 minus 8 root 3 එතන මෙන්න මෙහෙට එනවා 9 root 3 9 root 3 vertical එක check කරන්න 16 sin 30 is 8 that 8 took this 8 cancels හරිනේ 16 sin 30 is 8 16 sin 30 is 8 8 upwards එන්නේ මේක 8 downwards cancels එහෙනම් මේක තමයි final answer 9 root 3 AP හරිනේ 9 root 3 කොහොමද ඒක answer එකේ තියෙන්නේ 28 1 29 cricket bat principle of force movements right cricket bat cricket විතරක් නෙමෙයි hockey cricket ඔය bats ඔක්කොම ටික හරි 29 29 29. The diagram shows mass capital M tied with a string which runs over a smooth fixed pulley at the upper end of the rough inclined plane. The mass simple M is tied at the free end of the string. Initially, the system is at rest, but when the angle of the inclined plane theta is gradually increased at theta equals 60, mass capital M starts to slip down along the inclined plane. Starts to slip. What is that point? Limiting point. That is just going limiting point. Start to slip කියන්නේ limiting point. Right? Hint. That's a hint. If the friction coefficient between M and is 1 over root 3, the ratio M to M. Right. Again, a friction question. Right? Then a friction may a third question from friction. Capital M. Simple M. T. This says it's 60. Then mg sin 60. This is mg cos 60. Perpendicular reaction. Right. At 60, the mass just start to slip. Right. At the limiting point. Limiting point is an equilibrium. Right. Limiting point again. Then we can consider the equilibrium. Limiting point is an equilibrium. Right. Then at the limiting point, start to slip direction starts to slip. Go there. Slip down. All right. Then direction of friction is upwards. Identify start to slip down. Capital M slip down. Right. Direction upwards. Right. Then at limiting point. Just starting to slip. T equals mg. At limiting point, vertical equilibrium of simple M, T equals mg. Right? Then if you consider inclined equilibrium parallel to plane of capital M, mg sin 60 equals upwards T plus F. Right? Then mg sin 60 is root 3 over 2. T is mg, simple mg. Plus F, simple mg, plus F. F is mu r, mu is 1 over root 3. R is mg cos 60. R is mg cos 60, cos 60 is half. Right? G cancels. Right. मैं मेरा करूँ 2 दिया ना root 3 दिया ना मैं तेरा 2 root 3 दिया ना then we can multiply everything by 2 root 3. Right? You can multiply everything by 2 root 3 at once. Make 2 root 3 multiply 2 to 2 cancels. Root 3 times root 3 is 3. It becomes 3m. 3 capital M. And this becomes 2 root 3 simple M. Make 2 root 3 cancel plus capital M. Right? Take this to the other side. 2 capital M equals 2 root 3 simple M. 2 to 2 cancels. We need capital M over simple M. Capital M over simple M is root 3. Capital M over simple M equals root 3. Capital M over simple M, root 3. 29 2. Another one from friction. Thirty. What is the maximum angular velocity of a rotating plate with 20 centimeters radius that the object on the plate are not moved away when it rotates around its axle? The coefficient of friction between the plate and the object is half. Right. Then if this is the plate, maximum possibility of moving out is when it is at the maximum distance. Then friction acts towards center as a centripetal force, circular motion. Right. Then apply F equals ma towards center. F equals ma towards center, considering circular motion. Simple F equals ma. A is omega half r omega squared. M r omega squared. F is mu r. Mu is given half. F is mu r half. R is simple mg. M and radius. Radius, what is the action? 20 centimeters. 20 times 10 to the power minus 2 omega squared. M to M cancels, right? M to M cancels. G is 10, no? Then this is 10, this is 20, 2 times. Subject omega squared. This 2 comes here, it becomes 1 over 4, right? And when this switches the sides, 10 squared, right? 100 over 4, 25. Omega squared equals 25. Omega equals 5. 35. Right. So start last 5 questions. Ask if any questions. 31 to 35. 35 ఎక్కడ 30 ఎంత కలిపేసాం కదా. Okay. Right, 31. 31. What's the maximum velocity of a car with 90 kilowatts power and 500 kilograms mass when it climb a hill with an inclination 30 to 5? Coefficient of friction is 103. 30 to 5. Right. If the angle is given as a ratio, the angle is given as a ratio, right? So I think we met this before, which means when you travel up along the road for 13, elevation gain is 5. 30 into 5, right? 30 into 5. Maybe the angles එනවා කලින් තිබ්බනේ. මම හිතන්නේ මම පේපර් එකේ දැම්මා. නේද? මම හිතන්නේ දැම්මා. Right, මේ 13 5 දැක්කම මම ඉතින් මොකද මතක් වෙන්න ඕන? 12. Right? මේ Pythagoras combination එක. It's 12. Right? එතකොට දැන් අර පොඩි කාලේ වගේ විශ්වාදදා එහෙම ලියන්න එපා හොඳේ. 3 4 5 12 5 13 කියලා කියන්නේ most common combinations. Right? Okay. 103. This is the vehicle now. This is the vehicle. And its weight is 5000 newtons. 5000 newtons. The component of weight acts here is 5000 sin theta, and this component is 5000 cos theta. This is R, and friction acts F. Capital F is the traction force by the engine. Traction force by the engine. Right. What's the maximum velocity of car with 90 kilowatts power? And okay, then first you have to find this force, minimum force required. Maximum velocity, power velocity කියන combination එක ආවිලා තියෙනවා නම් අපිට කොහොමද choices නැහැ. එක equation එකයි තියෙන්නේ. What's it? කලිනුත් මම use කරා. P equals F. P equals F. Power velocity කියන combination එක ආපුවාම වෙන equations නැහැ. Power with velocity P equals F. Right, එහෙනම් මේ force එක හොයාගත්තා නම් හරි. In P equals F is the traction force. Right, force by the engine, traction force. එහෙනම් මේක හොයාගන්න ඕනේ. Then minimum F required is 500 5000 sin theta plus F. Right, 5000 sin theta. Sin theta කියලා කියන්නේ මොකක්ද දැන්? 5 over 13. 5 over 13 plus F is mu R. Mu is given 1 over 3 R equals 5000 cos theta, then 5000 cos theta 12 over 13. Right? Then this part is common, right? May cancel now. This cancelling 5000 over 13 is common. 5000 over 13 is common. Right? Then 5 plus 5000 over 13 common 4. Right. මේක මම simplify කරන්න try කරන්න නෑ ගොඩක්. මේක final answer එකක් නෙමෙයිනේ. 5000 over 13 times 9. මොකද තමයි force එක. Right? Apply P equals FV. P equals FV. Power is 90 kilowatts 10 to the power 3. F එක මේක 5000 over 13. 5000 over 13 9 V. Right? Cancel now. 10 to the power 3 to 10 to the power 3 cancels. 9 times 10. Right? 5 times 2. Then V equals 13 times 2. 26. 3. 31. 32. 32. The diagram shows a solid wooden cylinder with a uniform cross-sectional area floating 3/4 of its volume immersed in water and 1/4 immersed in oil with density 800. Right. Then this should be the oil. 1/4 is immersed in oil, VO4. 3/4 is immersed in water, 3VO4. Right. The density of wood is. Right. So when it floats, it's an equilibrium. Right. When liquid changes, upthrust changes, then there are two upthrust forces acting here from these two liquids, say U1 and U2, and mg acts. Vertical equilibrium, right? Vertical equilibrium, vertically upward forces equals vertical downward forces, vertical upwards U1 plus U2 equals vertically downwards mg. U is V rho g, right? U is V rho g. U1 immersed volume in liquid 1 is VO4. Rho is 800 g plus U2 immersed volume in liquid 2 is 3VO4. Density of liquid 1000 g plus we know m can be expanded as V rho from the object. Then total volume of the object into density of object. V2, V cancels. Right? And G2, G cancels. 200 here and 750 here. 950. 5. Law of flotation. Law of flotation. 33. 33. With considering, take down, law of flotation. We discussed more advanced questions in the class compared to this one. Make it lazy. This is average. Lazy, that's average. 33. With considering the air resistance, velocity time graph of ball dropped freely from a place vertically up to a horizontal table and bounced with non-elastic collisions. Okay, non-elastic. Non-elastic means energy is lost over time, right? When kinetic energy is lost over time, velocity decreases over time. Velocity decreases, but the entire motion goes under gravity, under gravitational acceleration. That's a good point, right? Doesn't matter how many bounces it bounces like this, make on the same line, right? This is on the same line, and from each collision, this decreases. On the same line, on the same line, right? And velocity decreases over time because energy decreases. Energy is lost over time, so velocity decreases over time. And about acceleration, this entire motion is under gravity. Gravitational acceleration is a constant, right? Then Vt is asked, gradient is acceleration, gradient should be unchanged. Gradient should be unchanged, right? Gradient should be unchanged. Third decade gradient change la. Second decade gradient change la. Fifth decade gradient change la. Now the tie is between 1 and 4 only. Tie is between only 1 and 4. G is constant. G is a constant. right? මෙයා කොච්චර bounce back වුණත් g is g, no, that's constant. හරිනේ? Then velocity should decrease over time. Velocity should decrease over time. It's 4. Having constant g, that's a good point you can get into a question. G is constant. G is constant. (34) is a common type. I think we met 3-4 times before. It's a common type. It's going to be a system in equilibrium under 3 non-parallel forces. In equilibrium under 3 non-parallel forces. Right? Center of gravity of rod is. It is in equilibrium under 3 non-parallel forces. Extend these two. Right? Extend these two. These two are intersected here. Then extend the line of action of mg as it goes through the same point, right? And check the respective point. Copy කරාට පස්සේ හොයන්න බෑ, right? You have to draw this on the same paper, right? නැත්නම් මෙහෙම කරද්දී ඉතින් angles වෙනස් වෙනවානේ. This is the method and that is not something new. මේක මම හිතන්නේ papers දෙකක හරි තුනක හරි විතර කලින් තිබ්බා. What's it? C or D? C. C the D. I think it's D. Online, is it C or D? Close to D, right? Close to D. If you get it in between, get the closest point. Right? It's D, 4. For 34. 4. 35. (35). Right. 35 do 35. No. That's a good initiative, ne? Okay. Right, 35. The time taken by an object to slip on a rough surface inclined at an angle 45 is n times the time taken by the same object to slip on a smooth surface inclined by the same angle. The coefficient of friction between the object and the rough surface is, right, friction again, right, combination of friction with linear motion. දැන් කලින් හදපු ඒවත් friction එක එකවත් එක්ක link වුණානේ. මේක linear motion එක්ක link එකක් තියෙනවා. Friction with linear motion. On the rough one, it takes more time, right? Because rougher the surface, higher the disturbance, and smaller the acceleration, right? Acceleration is smaller. When acceleration is smaller, it takes higher time, right? N times here, that is n times as the rough on the smooth plane. So this is rough and this one is smooth. This is rough and this one is smooth. right? Smooth and rough, right? Then if it takes time t for this motion, it takes n times t, nt for this one. That is given. That is given. Right? See that? I see. See. Take a scene and see. Right? Closer see. මට ඇඳලා බලන්න පුළුවන් පොඩි වෙලාවක් දුන්නා. චෙක් කරන්න ඕනද? කොහොමද ඔයගොල්ලෝ ඇඳලා බලුවද? Okay. See that? ඔයගොල්ලන්ට D. ඔය දෙන්නටම එතකොට D. C නේ. වර්තා C නේ. C. D. බලුවද? C. හරි නෑ. ඈ? කොහොමද vertical එක? ඒ D වගේ තමයිනේ. පොඩෙන් මම බලලා කියනවා. Give me 1 second. පොඩ ඉන්නේ ඒක. D. It's D. ඇංගල්ස් වල පොඩි නේද? මේකද? හා? දැන් මේ ස්ට්‍රින්ග් එක කවර් වෙලානේ තියෙන්නේ. හරි. දෙන්න වෙක් ගන්න. හරි closer to D එනවනේ නැද්ද මට එනවා මම ස්ක්‍රීන් එක ෂෙයා කරන්න it's closer to D මේක පේනවත් ඇත්ත සමහර විට පේන්නේ නැහැ නේ check කරලා බලන්න I think it's closer to D between C and D තමයි D වලින් intersect නම් වෙන්නේ නැහැ intersect වෙන්නේ නැහැ it's true but it seems closer to D right ඒක confusion එකක් එනවා නම් හරි නැද්දරම එනවා නම් I will consider both C and D මේ කවන එහෙම C and D දෙකටම ගන්න මේ but I feel like it's close to D නේ ඇති මේකේ මං රූල් එකෙන්ම ඇඳලා බැලුවා එතකොට වර්ධින විදියක් ඇත්තෙම නැහැ මේ ඇඳලා බලන්න I think it's close to D close enough it seems එහෙම නැහැ වගේ නම් you can consider both C and D that's fine right ඒක diagram එක පොඩක් I mean not the best right ඒක confusion එකක් තියෙනවා නම් දෙකම consider කරන්න 3 or 4 that's fine if it is confusing consider both 3 or 4 right 35 right ඒක පොඩි ගානක් නේ ඒක ඇත්තට වෙලා ගන්න එක තවරාද මේ diagram එකේ අවුල තියෙන්න පුළුවන් මේ අවුල නැහැ CD හැම දෙයක් ගන්න with respect to your thing ඇදේට අරලා තියෙන්න බෑ ඉතින් හරියට strings එක cover වෙලා තියෙන උන ගහන lines එකෙන් and vertical should be exactly vertical හරිද vertical කියලා මේ වගේ වැඳලා බලන්න එපා right මේ මම angles උත් measure කරලා නැන්දේ මේ පොඩ්ඩක් විතර D වලට close but පොඩ in between තමයි අවුලක් නැහැ consider both C and D 35 time taken by an object hari the coefficient of friction okay then about this one see mg acts downwards right then this component is mg sin 45 if you have 45 no need to like carefully check these angles always all the angles are 45 no? with right angles I එහෙම නිකන් අර 36 වගේ බල බල ඉන්න ඕනෙත් නෑ mg cos 45 sin 45 cos 45 මාරුණත් ගමවුත් නෑ it's 1 over root 2 ඒ නිසා මේ 45 කියලා කියන්නේ ටිකක් ඩීල් කරන්න ලේසි පැලිමයක් right now we need to find the acceleration here to find acceleration apply f equals ma downwards the plane friction is acting upwards right apply f equals ma downwards the plane mg sin 45 mg sin 45 mg sin 45 minus f equals ma right mg sin 45 minus mu r r is mg cos 45 equals ma right m cancels throughout m2 m cancels g sin 45 g sin 45 is 5 root 2 no 10 over root 2 5 root 2 තේරෙනවනේ අර නේද g sin 45 කියලා කියන්නේ 10 over root 2 this is 5 root 2 so this is 5 root 2 right minus mu g cos 45 5 root 2 so acceleration is 5 root 2 is common 1 minus mu right මම මේක a1 කියලා consider කරන්න a1 is here 5 root 2 1 minus mu right Then acceleration here on a smooth plane, no need to write the equations if you are familiar. Gravitational acceleration is vertical downwards. So component of gravitational acceleration along this line is g sine 45. G is acting downwards, this is g sine 45. F equals still you will get g sine 45. Any vector can be dissolved. हम एक element acceleration को dissolve करना. G sine 45. Right? Then A2 here is g sine 45. G sine 45. G is 10. Sine 45. 1 over root 2. That is 5 root 2. 5 root 2. A2. Right. Accelerations are known. Then time में करने connect कर गया right? Second. Okay. We have to connect time. Time में connect कर गया Same inclined plane, right? Same inclined plane. Then apply equation like s equals ut plus half a square. Right? Acceleration के दिए लोड displacement के दिए लोड. Let's consider distance of the plane as s. S equals ut plus half ad square. Right? Ut is 0 because u is 0. Then s equals half, for this case a1 t squared, no time here nt, then it should be nt squared. Right? I will consider this as 2. Do the same here. S equals same s because same inclined plane, half a2 t squared. Right? S equals s, no? Right? Equalize these two or divide. Right? S equals s half a1. This is n squared t squared. This is half a2 t squared. T squared to t squared cancels. Right? Half to half cancels. It says a1 n squared equals a2. Right? A1 a2. That's it. A1 5 root 2 1 minus m. 5 root 2 1 minus m. M 1 minus mu. Right? Then a2 5 root 2 n squared. N squared. 5 root 2 to 5 root 2 cancels. Right? Then subject 1 minus mu. 1 minus mu is 1 over n squared. Right? Subject mu equals 1 minus 1 over n squared. 1 minus 1 over n squared. How are the times equal? Times are not equal. T and nt. 1 minus 1 over n squared. 3. Right? See how friction is combined into linear motion. This is a linear motion one. Linear motion, Newton's laws with friction. Right? Linear motion, Newton's laws with friction. Okay. So any questions from what we have discussed here so far? 35 MCQs. Any questions? Right, take it down. Frictions questions and friction is a definite MCQ you are getting in the exam, at the main exam. Right? Friction na friction connected. Sometimes friction can be connected to linear motion, sometimes rotational motion. Right? Friction is everywhere. Right? Connect friction friction right? Self adjustment region friction dynamic. This friction is dynamic. Okay, so if no questions, we wind up. Next week can New Year, I mean, no, other first 8. Right, next week we will have the paper 2 of this one, and I'm planning to add 3 structured essays and 3 essays. Right, a structure again ඊළඟ papers එකයි until mechanics over mechanics ඉවර වෙච්ච ගමන් මම ආයි questions ගන්න වැඩි කරනවා. Right, يعني up to mechanics 50 MCQs වගේ දාලා ඉච්චර වැඩක් නැහැ. ඒතකොට mechanics questions unbalanced වෙනවා. Right, okay, 3 structured essays and 3 essays වගේ එකක් එයි. Right, so sometimes it might not be enough, I mean time might not be enough to write the entire paper during the class. Then what we can do is I will let you start writing papers 6:30 onwards. Right, ඔයගොල්ලන්ට 6:30 ඉඳන් ලියන්න පුළුවන්. මම online එකත් 6:30 වලදී open වෙන්න දාන්නම්. Right, so 6:30 වල ඉඳන් ලියන්න මම discussion එක 7 වලට start කරනවා. එතන 30 minutes තියෙනවා කියලා කියන්නේ ඔයාලට ලියා ගන්න time එක ඇති වෙයි. නැත්නම් මේ මට questions 6ටම time දුන්නොත් එම discussion එකට time එක මදි වෙනවා. Right, let's see. Right, let's see එක කරලා බලමු. දැන් මේක 35 නම් අද ටිකක් balance. ඒක calculations ගොඩක් වැඩි වුණොත් 35 balance වෙන්නේ නැහැ. දැන් මේකේ calculations balance වෙන්න දාලා තියෙන්නේ. නැත්නම් අර මේ පාර මේ paper එක වගේ calculations විතරක් තිබ්බොත් එහෙම balance වෙන්නේ නැහැ. statements එක තමයි ඒක balance වෙන්නේ. මේ බලමු. Okay, anyways, you can start writing the paper at 6:30 next week onwards. I will start the discussion at 7 anyway. You can start writing at 6:30. Right, ඒක මම online එකේ හදන්නම්. Okay, මම meeting එක 6:30 වලට start කරලා තියන්නම්. එතකොට හරිනේ? Okay then, if no questions, we'll wind up. Right, see you in the next class. Stay safe. Good night and goodbye.